Hey folks, Quill18 here, and welcome to the continuation of our 2D tile mapping system for Unity 3D. So right now we just have this single quad, to use that term, these two triangles making up a perfectly flat surface, but we want to break this down and have something that's quite a bit more interesting to look at. So that's fine. We're going to go back to our script. So we're going to say we want a tile map that is made up of, well, let me take a think. This particular map that we're looking at is actually twice as wide as it is tall. So that's a pretty good start. Let's say that we want a map that goes, I don't know, we want int width equals 100, int height equals 50. Now, these terms are what you're going to use, but the height is more like the north-south distance as opposed to actual terrain elevation. So you might want to literally just use different words if it makes it clearer for you when you're designing your engine. Words kind of matter in terms of perception, keeping things straight. I'm going to use this. It's going to be fine. Actually, you know what would make a lot more sense? We're going to call it size X, size in the X direction, and then we're going to call it size Z. Because X, let's go into the vertical, X is your left to right, Z is your back and forward, and then Y is your up and down. So it gets a little confusing sometimes because when you're switching between these 2D bitmaps where you've got just X and Y and then this particular thing. I could also resolve it if for whatever reason I want to sort of set the map up vertically, then I could have the Y this way and the X this way. So then it would literally be height and width and then depth. But I've decided that it makes way more sense, obviously, if the map is flat, when you're looking down on it. So in which case, then it is a X and Z coordinate system. So, okay, that'll work perfectly fine. We're going to do that. So what we're going to do is we're going to get rid of all this hard-coded in data here, because obviously that's not going to work. And everything else down here stays the same. This is going to be identical. We need a couple of tweaks over here. Mostly we need to change our size. So this size X and size Z, what does this represent? What is this size? Well, we're going to say this is the number of tiles on our map. We want 100 tiles left to right and 50 tiles top to bottom. Now a tile from our beautiful paint program, let's start fresh again. One tile, we know is made up of two triangles and it's made up of 4 vertices. In our previous coordinate system, we had 0, 1, 2, and 3. Now, if we want a map that is 2 tiles wide, so let's draw another tile over here. 2 tiles wide looks like this, and I don't know, we'll just keep numbering them this way. I mean, I know it no longer makes any sense, but it's fine. So it looks like this. So, and we could add another one, just for good measure. And we will call this 6 and 7. So this map is 3 tiles wide, but it is 4 vertices wide. So it will always have one extra vertice of width than tile because it needs this last bit, right? It's got 1, 2, 3, and then it's got the one extra edge sort of closing things out. And it's the same thing vertically. This particular map is 1 tile high, but it still has 2 vertices vertically this way. So, okay, how many vertices are we going to need? Well, we are going to need quite a bit because, and we can put in placeholder in here. We can say vertice size X is equal to size X plus 1. And the vertice size Z is equal to size Z plus 1, which means that num verts is equal to v size X times v size Z. Again, if this is a 4 by 2, 4 times 2 is 8, and that is exactly the number of vertices we need. So in this particular case, it's going to be quite a bit more. In fact, let's bring up the calc and say, so 101 times 50 is 5,050 vertices. And that's a fair amount, but it's really not. The performance of that is going to be trivial, and I'll help to explain why in a little bit. So we now know the number of vertices we need. Great. Okay, number of vertices. Excellent. Next question, how many triangles do we need? All right, that's a good question. Let's go back to our paint. So here, this map has 3 tiles. I guess that's the other thing I can do. I can have a placeholder in here for num tiles, which is simply going to be size x times size z. Okay? So this map has 3 tiles. Each tile has 2 triangles. So that's simple. That is 6. So, okay, num we'll call it num tries, is equal to num tiles times 2. In fact, let's move these. This is fine. Number of triangles is equal to the number of tiles times 2. Okay, and each triangle is actually a trio of ints. So we still have to say num triangles times 3. Okay, that's good. Normals is equal to the number of vertices, and the UV coordinates is also equal to the number of vertices. Awesome. Now we just have to generate them. And for that, we're just going to use a pair of for loops, because why not, right? We're going to say for int x is equal to 0, x is less than size x, x plus plus, and then we're going to duplicate this for our z. Okay, so now we're going to loop through and do every single tile one at a time. Sure. This works okay, except not exactly. The reason is we're going to be doing a tile, and we know that a tile is made up of the 4 vertices, but which vertices are they? I'm not sure. This is not quite the right approach. Instead, we're actually probably better off making 2 passes. The first pass, and you can see there's obviously a relationship here. The verts, normals, and UVs are sort of one group, and then the triangles are another. We're going to create all of these first, and then fill in the triangles afterwards, because the loop logic that works best for them is slightly different. What I'm going to do, first of all, is I'm going to initialize the x and the z outside of here, because I'm actually going to need them twice. And we are going to loop through the vertices first. We're going to create them one at a time. So our tiles, we're still going to go with a 1 by 1 size, just because it makes the math pretty easy. Although, well, let's do this. Let's do something like int tile size equals 1. Actually, probably better to make this a float, because maybe we want our tiles to be 1.5 units wide in terms of unity. That's fine. There's nothing wrong with that. We're going to go with a 1. And okay, so we are creating vertex. Well, the first one will be 0, but obviously we need some sort of coordinate. Well, it's going to be z times the width, basically, of our map, which is x. So on the first time we go through, this is going to be 0. The whole first row is 0 plus our current x. So it's going to go 0, 1, 2, 3, 4, 5, 6, 7. And then at some point, this is going to loop around. It's going to end that row. Well, actually, just for the sake of this storytelling, I'm going to invert the way these loops happen. So we're going to end. This is doing a row. It's going to start on the left-hand side. It's going to go until we hit the right-hand side. And then it's going to exit out of this loop, and it's going to increment z to be equal to 1. And then when we come back over here, it's going to, z is going to be 1, so it's going to be the width of vx. So it's going to be, we're going to be at 101 plus 0, 101 plus 1, 2, 3, so on and so forth, and that's great. So we create a new vector 3, and we need to feed it some coordinates. So again, the very first one we do will be 0, 0, 0. And in fact, the y will not change at this point. We're not creating any sort of height elevation data. Height elevation? Derp, derp. Terrain elevation data. Everything is perfectly flat at this point, and that's okay. So we're going to leave that as a 0. So our x coordinate is going to be, well, I guess it's just going to be our x, 0 through 101. That's true if we were using a unit of 1, but we will multiply it by tile size, which doesn't change anything here, but that's going to be fine. And our z coordinate is going to be the same thing, z times tile size. And of course, these tiles don't even have to be square. You could have tile size x, tile size z. If your tiles are kind of an odd shape, that's fine, but most tiles are square, so we're going to do that. Hexes are a whole other topic that we will probably talk about at some point, but not as part of this series. So that populates the vertices, which is good. The next thing we have to do is populate our normals, and it's going to be the same normal index, but the normals at this point are just going to face straight up. So we're going to go vector 3 dot up. And then what about the UV? Well, the UV index is going to be the same. That's how you know if you're being sunburned. Then we need to create a new vector 2 for this. Well, all right, what's involved in doing this? So we know we have to feed this a number from 0 to 1 and another one from 0 to 1 that explain how far along we are. Oh, I lost my other picture. How far along we are in our texture, right, as we go forward. So the first vector has to be a 0. The last vector has to be a 1 so that we hit these edges properly. Yeah, let's go with that. So how do we do that? Well, we need to do a little division. So we know the size of our x. Actually, it's this size, right? And we know our x here. So what we need to do is say, okay, let's just do a little bit of comments. When x is at the 0, when this x is 0, that's fine because we want our uv.x to be equal to 0. When x is at, in this particular case, it's going to be 101, then uv.x needs to be equal to 1. And we can do that by saying that uv.x is equal to the size of our x minus x. No, that's not right. Our x divided by our v-size.x. That will enable the relationship we're looking at, with the exception that this will technically, these are integers, and when you do integer division, you sort of just get, well, not what you want. Because this will only equal 0 or 1, and we don't want that. We want it to be, we want to convert it to a float, which is fine. We'll just apply a cast to a float here. Like that. This, I keep thinking that I've done something wrong, and doing math on camera is never advisable, but I think I may have actually gotten it here. So we're going to do that, and then we'll do the same thing over here, but with the Z. And we're going to find out, pretty quick what kind of mistakes we've made once we get in there. So that's our first pass, and then we're going to do a second pass. This one based on the actual size. And in each one of these, we're going to create a pair of triangles. So it's going to be triangles with an index. And again, let's use our first example, right? We had triangle 0 equal to some number. I'll just put in 0 for now. So that's the first triangle, second triangle. 2, 3, 4, 5. So in our structure here, we can kind of see what's going on. Now let me recreate this one more time. I swear at some point we'll be done. So right now, the way our algorithm is ordering our vertices, it's going from left to right, row to row. So our vertices are actually going 0, 1, 2, 3, and so on, and 4, 5, 6, 7, and then can repeat as needed, right? So in practice, it's actually going to go from 0 to 100, 101 to 200 ish to a 1, I guess. Yeah. Math on live things. Don't do it. So we have to keep this sort of progression in mind. So our first triangle, and again using the hard coding, the correct answer for our triangle, so again we are sort of assuming our triangles are in this order, Of course, there's nothing that would stop us from making our triangles like this instead. That's fine. We can totally do that. I've just arbitrarily chosen this particular orientation for it. It makes no difference whatsoever. So here, all right, so our first triangle, our 0 is 0, and that's good. And then our 1, our next point, so we start here, and then we go down to here. This is, in this particular case, is going to be the width in x plus 1, and then the width in x plus 0. Again, hard-coded in. This will be the correct answer in this particular scenario. And actually, I can test that. I can say, all right, let's just keep going. Our second triangle is going to be at 0, and then 1, and then down to the bottom here, which is actually this guy here. You know what? Let's run it this way. What we're going to end up with is 550, or was that the number of vertices I had? Yeah. We're going to end up with 5,000, actually 10,000 triangles in the same place. Well, in the same two places, right? Because we've got a square. But this technically, barring the fact that I probably made some glaring, horrible error somewhere, this should actually work. So let's give it a try. First, any syntax errors? Really? I'm as shocked as you guys. Play. Really? Alright, not entirely. I expected errors, not literally nothingness. I'm really very confused. Z, well, X, comma, Z. Well, it runs through my triangle array. And it must be running through here. Are my coordinates wrong? Well, let's give it a try. Let's grab this. Keep that copy there. And well, we can't just fix that. That's no good. I'm sure you guys have noticed the error already, but I certainly have not. Oh, well, partially one of the issues is it's not going to be doing every single triangle here, because we're only populating the first 6. And that might be the problem. I'm surprised there's no actual warning or error message being generated, though. That we kind of have an incomplete structure that we're passing here. Well, I guess everything gets initialized with zeros, maybe? I'm actually not sure. All right, let's go and do this a little bit more. So again, the Z and X is defining a square. So we'll do something like int, we'll call it square num, is equal to Z times, actually it's more like square index. The square index is Z times size X plus X, which will be this, and then the offset. Number of triangles. Oh, that is not right. We want the tri-index, which is equal to the square index times 6. So, let me explain in a sec here. So the first square index will be 0, and the triangle index, or the triangle offset, I suppose you could say, starts at 0. But the next time through, the square should be 1, and the triangle, again, offset is actually more accurate here, will be 6. So this will be, so the first time through it'll go 0, 1, 2, 3, 4, 5. The second time it'll be 6, 7, 8, 9, 10, 11, Next time through, 12, 13, 14. All right, so now we're populating that. I'm still not convinced that our coordinates here are right, but we are at least going to populate every single triangle that we actually have. And I will turn off this debug since we know that it's actually running now. And it's correctly going through all the numbers. Indeed it is. Hit play. I have to say, so it's got to be something up here with my coordinates. So I'll add a couple extra debug logs. Done triangles. Done mesh. Done verts. We should see these 3 messages. Indeed, and quite quickly. Okay. Well, here's a question. Do I have my coordinates set right? Yeah, they're not public, so they're in there. That's fine. And yeah, it's certainly running quite a bit. Okay. Z equals X. Z is less than Z. Z plus plus. X equals 0. X is less than X. X plus plus, so that's working fine. Times tile size, Z times tile size. This should also be fine. I suppose I could do a debug.log of that to make sure that's being set okay. I really apologize, guys. I mean, I think that there's value in seeing the debugging. There you go. It's going to take a while to run always. You know, like the steps involved in doing that. I mean, it certainly seems to be iterating through this perfectly fine. Goes from 0 to 100. It starts at 0, 0, ends at 50, 50. All the coordinates are great. Is it a visibility thing? Make sure that the mesh is actually being set over here. And it's going to take longer to run because it's got to fill this in. It's got a mesh with no name. It's got the graphics here. If I were to set this to the none, oh! Well, now that's interesting. Okay. So, all right. That's good. Okay. So we are properly generating. We're generating something. Now again, all the triangles are in one place. We're going to leave off the earth material for now because it probably means there's something with my UV coordinates. So that's good. I mean, debugging, you got to try all kinds of different approaches to it. I suspected that that was a possibility. Oh, do I still have this big debug command? Let's get rid of this because that is just going to crush all the things. So, right. So by getting rid of the texture, we're actually seeing the raw mesh over here. Everything's in one place because this thing is not correct yet. So we're going to go and tackle these triangles so they start showing up in the correct place again. So, and that's fine. That's pretty easy to do. It's because of these hard-coded numbers in here. In fact, just to make things pretty, we will do something like that. Okay? It's because of these. This part here is great, but we need to change the offset, or there's a couple of different ways I can think of doing this. In fact, again, let's F2 this. Let's call this try offset. Oops, forgot I have to hit enter there. You hit F2 and you can do this sort of rename. So what we need a vector offset as well. Vert offset is equal to actually it's just the X and Z and all that. So yeah, it is, isn't it? Yeah. It's this, and then Z times size, V size, X. Again, I'll give an explanation of this in a second. So, where's my drawing? So again, later on, we have looped through another go, and where's the eraser tool? That is not very convenient to this size. I should have changed the brush. All right, we've done that. So we are at 8. What tool was I using before? Oh, brush. 8, 9, 10, 11. Because V size X in this example is 4. But size, remember that these are not the same, size X is equal to 3 in this example here. Okay, in fact, maybe I should change the numbers in the actual program to resemble these coordinates. Size X, V size X, 3 and 4. So later on, let's say we're at the point where we're trying to generate this triangle here. Well, or rather the pair, but let's concern ourselves with the triangle that we're going to call A at this point. So here we are at, in our loop, we are right here, right? And we have X is equal to, this is 0, 1, 2, so X is equal to 2, and Z is equal to 1. Because this is the 0 row, this is the 1 row. So Z of 1, X of 2. So to get to this point here, we are going to say Z times V size X. So V size X is 4. So again, we're stepping through this here. So we're at Z of 1. We're at a V size X of 4. V size X of 4. So that is 4. 1 times 4 is 4. Plus the X, which is 2. So now we're at 6 plus 0. Well, that's great. We're at 6. And then the next point, which is, oops, I forgot. This is the wrong triangle. Again, let me grab the eraser here. Shoop. Get rid of the A, because I'm being silly. Our triangles are cut this way, of course. Oh, straight lines. I should have used more of those. So now the next point is this one here. So we are having to say, it's the same start of the equation. This bit here still comes out to 6. And then we are adding the V size of X, which is 4. So that brings us to 10 plus 1, which is here. And then for our third point, it's the exact same thing, except instead of plus 1, we're leaving it at plus 0, which means we end up at 10. So that is working exactly the way that it should. Except apparently my tabs aren't lining up the way that I want. There we are. So that is working out great. And then what we will do is we will duplicate this for the next triangle. But we have to change things ever so slightly, of course. Now, the origin, they both start at the same place, so this first line is great. And the last point is okay-ish. The last point is actually this line here. So we're actually going to call this one 5. And what is number 4? Well, number 4, actually, let's get rid of this. Number 4 is the same as our first point, but with a plus 1. Like so. I hope that's clear. You can rewind it and replay it as much as you want and watch my beautiful drawings once more. But this should work unless it doesn't. Hey, hey! Alright, so there's obviously something not right. We'll get to that in a minute. That is really weird, actually. Why would it do that like that? I've got something off. Some of these triangles are not right. Let me just grab a random one for the middle. For Z equals 25, Actually, we can just do it this way. Z equals 25, X equals 50. So this is going to be a middle triangle. It's just going to generate one in the middle. And I was going to say, I've seen this before. So there's two possibilities here. Either it is grabbing the wrong vertex, or the vertex is set wrong. Now, I'm 100% sure, well, 99% sure, it's simply grabbing the wrong vertex. The reason is half the triangles appear to be fine. See, this triangle is perfectly fine. And in fact, if I remove this, and these, and then run it again, we're going to get a perfect plane except only half the triangles. But everything looks exactly right. Okay, there's some like aliasing weirdness, but no, everything is good. Now, if I flip this around, it is stupid and bad and wrong. So, I'm actually really curious. Like, can I figure out exactly what I did wrong from here? Well, I'm thinking there's an X and a Z inverted. I don't know. Oh, hey! What is that? Guys, you gotta tell me when I make those kinds of mistakes. Boom! Excellent. Everything is fine. Okay, good. I was worried it was going to be some like harsh math error, but typos I can deal with. There. Now we have a perfectly plain plane. Now, on a perfectly plain plane, what happens when we throw the material back in? When we look from the top, nothing happens. When we look from the bottom, everything is there. And the reason for that is my triangles are facing the wrong way around. So, despite my beautiful little drawing and planning here, I have somehow managed to invert all my triangle orders. Now, one quick way to fix it is literally to do something like this. Now my triangles should actually just be flipped the other way around, and everything should be awesome. Oh yeah, I forgot that I was doing it in the play mode, so it didn't stick. There we go. So now we're looking down, and if we look at it from the bottom, nothing happens. Okay. How did I end up, though? I must have messed something up somewhere. At a glance, I'm not seeing where I messed up my sort of clockwise-ness. That's okay. And just so that I keep my indices in order, we'll do this. So now, yeah, now it's going 0, 4, 5. It's going counterclockwise. Which probably means that my vertices math is wrong somewhere. I don't know. Can't see it. Doesn't matter. So that's fine. Now we have a decent map. Now one of the things at some point you guys might start to say is like, well, doesn't it suck that you have to hit play all the time? Wouldn't it be nice to see the map in edit mode? And yes, definitely. There's a few ways of doing it. One of the easiest, like first ways to do it is you can tell it to just run the script in the editor. There's a editor, execute in edit mode. So if I do this, and then I tab back over, boom. In fact, what I can do is I'll make sure all my changes have been applied here. I can delete this map, and I have a prefab, and I drag it into my view. And in fact, even here, you can see, like, right away, bam. Because what happens is as soon as it enters the editor, the start runs, which is the build mesh. Now, when I hit play, it'll rerun that. It'll sort of clear this all up and run it again. Oh, you just have it in a stupid place. That's the problem. It'll run it again. What you might get from time to time is a message about like objects leaking and being garbage collected or something to that effect, and that is totally fine and you don't have to worry about it. But this is not literally the cleanest way of doing it. The other problem with this is that it doesn't change. So let's make these publics. Public, 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 save. So now on my tile map, I have some great parameters I can change. Now I decide, you know what, I want the tiles to be 5 by 5. So I click that, and nothing happens. Well, the reason is it only runs on the start, right? So if I delete this and I go in my tile map prefab and say, oh, I want them to be 5 by 5, and then I drop this in the game world, now I have a much bigger map all of a sudden. It's because it's taking that into account, but it only runs at the one time. What you can do is you can write a custom inspector plugin for your tile map. It's actually not terribly hard to do. Oh, what the heck, we'll look at it. Next video, I'll make a video right now, and we will look at making a custom inspector plugin to let us rebuild this map. It's not hard, and it's a really cool trick, and it'll save you a heck of a lot of time. See you next time, folks. Bye-bye.